Okay. What questions?
Can we go over the set questions? So I believe it's number 14.
Yes. Number 14, yes. Okay. So for number 14, it tells you that the universal set, so all the things we're dealing with is the set X, and it's the numbers 0 through 9. So those are all the numbers that should be on your Venn diagram. There we go. And then it tells us that set A is the numbers 1, 2, 3, 4, and 5. And then B is the numbers 0, 2, 4, 6, 8. Okay, so when we go to draw our Venn diagram, this is part C, but I'm gonna go to the Venn diagram first. When we go to draw that, so this whole thing has all the numbers for X inside of it. So 0 through 9 needs to be somewhere in here. And then I have two sets, set A and set B. And then I need to figure out where they go. So the way that I like to do it is I like to go from the universal set. Start off with 0. Oh, let me let her in. Hidden it. There we go. Hey, Elizabeth, can you hear me? You can either chat or you can.
Yes, I can hear you. And sorry I'm late.
No, you're good. If you want to just send a message or you can just talk to your microphone, that works too. We're doing number 14. So when you're putting these numbers in your Venn diagram, I like to go from the set X so that I don't miss anything. So I make sure, excuse me, I make sure I get all of my numbers in my box. So the number 0. 0 is not in set A, but it is in set B. So 0 needs to be over here in the B circle, not in set A. And then for number 1, the number 1 is in set A, but not B. So it needs to be over here in set A, but not B. The number 2 is in set A and set B. If it's in A and B, then it needs to be in the middle. The number 3 is only in set A, so I'm going to put it only in set A. The number 4 is in set A and set B, so it's going to go in the middle. The number 5 is only in set A, so it's going to come over here on set A. Number 6 is only in set B, so it's going to be over here in set B. Number 7 is not in set A or set B, but it needs to be in this box, so it's going to be on the outside somewhere. 8 is only in B, and then 9 is not in A or B, so it's also going to be in the outside somewhere. It doesn't matter where, just put it anywhere on the outside. So that was like part C, drawing the Venn diagram. And then part A asks for A union B. So A union B means add the sets together or write every single number that is either in set A or in set B. So you can do that by looking up here, or you can look at your pictures. If you look up here, you're just writing all these numbers and you don't repeat them if they repeat. Here, you're just writing all the numbers in the circles, because if it's in set A or B, then it's in a circle. And you can put them in order. You don't necessarily have to if you don't want to. If you look at the circles and just go from there, like 1, 3, 5, 2, 4, 0, 6, 8. Or if you really want to put them in order, it would be 0, 1, 2, 3, 4, 5, 6, 8. So either one, I don't care which way you do it. For part B, B is a intersect B. So this is the intersection. What numbers do they have in common? Again, you can look at your sets here and compare, or you can look at your Venn diagram. On the Venn diagram, the intersection is going to be that middle part. So that would be the numbers 2 and 4. Questions about that? Do you also want to do 15, the word problem?
Yes.
Okay, we're going to do 15. Okay, so it says 26 students are in a math class. 15 of them went to the tutoring center for help. 7 got help from the teacher. Some did both, and 9 of them did nothing. How many did both? So if I were going to draw this Venn diagram, the box would be the 26 students. So there needs to be 26 students total in this box. My 2 different circles here. One would be the tutoring center, and then the other would be tutoring from the teacher. So this is the tutoring center. I'm gonna say this one over here is the teacher. Uh-oh, I let her in. Okay, so is it Davida? Is that how you say your name? Oh, she's connecting still. We'll give her a second. Put this over here. Okay, so it tells us that 15 people went to the tutoring center. So remember, we have a number here on the outside and we have a number here on the inside, and those 2 numbers need to add up to be 15, because when it says 15 people went to the tutoring center for help, that could be people that only went to tutoring, but also people that went to the teacher also. So these 2 numbers need to add to be 15. Okay, so you can put that if you needed to, if that helps, that these 2 are going to add to equal 15. And then the other 2 numbers, 7 of them got help from the teacher. So that means the middle number and this outside number, those 2 numbers are going to add to be 7. Okay, and then it tells us that some people did both. So that's the number in the middle that we're trying to figure out. And then 9 of them did nothing. So 9 of them are going to be on the outside somewhere. It doesn't matter where you put it, just anywhere on the outside. So to figure out these 3 numbers, first thing I need to do is take my 26 students and subtract 9. So 26 minus 9 is 17. So that tells me that 17 students are the ones in the circles. So these 3 numbers need to add up to be 17. So you can kind of reason through this. There's like a few different ways to do this problem, and it seems like I always do it the weird way, like not the way that a lot of people don't do it. The way that I think about it is if these 3 numbers have to add up to be 17 and these 2 have to be 15, how much does that one over there have to be? It'd have to be 2, right? If all 3 have to be 17 and this is 15, that number would have to be 2. So again, the reasoning there is if 17 total are in the circles, minus if 15 are in the tutor circle, that leaves 2 in the teacher only circle. And then from there, it's like a domino effect. Like you could do that same reasoning to figure out this number, or I can kind of do my domino effect to figure out the rest of them. If these 2 blanks have to equal 7 and this one's 2, that tells me this middle number has to be 5. And then if these 2 blanks have to equal 15 and this number's 5, that means this blank over here has to be 10. So if you can get one number, then like you can kind of figure them all out pretty easy from there.
So we would always subtract 26, like the number total?
Yes, you always take off the people who didn't do anything. You take that from your total number. That's the first thing you do. And then from there, that 17 students, you're going to subtract off one of the numbers. You could subtract off the 7 and you would have found this one over here.
Okay.
Does that make sense?
So it really doesn't matter.
It doesn't matter which way you go about it. Just start off finding one of them.
Gotcha.
And the big thing here is, what does the question ask? The question asked, how many did both? So where's the both here? Right there in the middle. Yeah, so this is the both. So 5 did both. And the way you can check your answer on this is see if all 4 of these numbers add up to be 26. If you did it wrong at all, they will not add up to be 26. So we can double check 9 plus 10 plus 5 plus 2 is, it's 19, 20, 21, 26. So it worked there. Okay, what else?
I don't know if anyone asked, but I had a question on, I think, let me look, it's number 5. It says count from 1 to 10 in base 10(3).
Okay, yes, lots of people always have questions on that one. Let's do that one. So for number 5, we're in base 3. And when it says count to 10, it just means like give all the numbers from 1 to 10 in base 3 form, essentially. So the idea, let's go over what base 3 is. The unit here would be 3 to the 0 power, which is just 1 unit, right? The long here would be 3 to the first power, which is 3 units. Okay, so once I get to 3 units, I put that together to make a long. And then 3 to the second power, that would be the flat here, which is 9. So 9 units make a flat. And then the cube here, 3 to the third power is 27. And I'm only counting from 1 to 10. So I'm not going to get up to a cube here. I'm only going to use a flat. So for the number 1, I think on your test, it's like in boxes. I actually haven't made your test, but usually I always put it in boxes like, let's do it. So like this is where you would put 1 and 2 and 3 and 4. I don't have enough boxes, but 6, 7, 8, 9, 10. Okay, so for the number 1, for 1, 1 unit is still just 1 unit in base 3. So it would just be 1 unit still in base 3. So it's the same notation there. Two units in base 3, or sorry, 2 units in base 10 is the same thing in base 3. It's still just 2 units in base 3. And if you need to like draw a picture, you're more than welcome to. Like here's, there's your 1 unit. Here's your 2 units. Here, for 3 units in base 3, once I have 3 units, I put that together and make a long out of it, right? So this would be 1 long, 0 units in base 3. For 4 units, again, 3 of them makes a long, and then I have 1 unit left over. So that would be 1 long, 1 unit in base 3. For 5, if you want to put 5 dots, again, 3 of them make a long, and then I have 2 units left over. So this would be 1 long and 2 units left over. For 6, I'm going to put 3 units together to make a long. I'm going to put another 3 units together to make a long. So that would be 2 longs and 0 units. For 7 units, I'm going to put 3 units together to make a long, another 3 units together to make a long, and then I have 1 unit left over. So that would be 2 longs and 1 unit, and that's in base 3. For 8, that would be 1, 2, 3, 4, 5, 6, 7, 8. Again, I'm going to put 3 units together to make a long, another 3 units together to make a long, and then I have 2 left over. So that would be 2 longs, 2 units in base 3. For 9, we know that 9 makes a flat. So when I'm doing this one, 6, 7, 8, 9. These 3 make a long, these 3 make a long, and these 3 make a long. And since we're in base 3, 3 longs make a flat. So it would be 1 flat, 0 longs, and 0 units in base 3. And then 10 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We just did 9. We know that 9 units is a flat, but you can go through that again. 3 make a long, 3 make a long, 3 make a long, 3 longs now make a flat. And then I have 1 unit left over. So it is 1 flat, 0 longs, 1 unit in base 3. Does that help, Elizabeth?
Yes, I just didn't really understand. And when I looked at the number 5, like where you had worked it out, I was really lost.
Okay. Does this help though?
Yes, it does.
Okay, so it'll just ask you to count. I mean, I haven't made the test yet. It may be like count from 10 to 20 in base 4 or something like that. Okay, so it'll just be like basically taking numbers that you can literally draw the dots out and just converting them over to a different base.
Okay, thank you.
You're welcome. What else? So on the problem solving one, just look over those problems. Like you'll just have probably two to three, I'll probably be 2 word problems on there, and I'll ask you to do a specific way on it, and they're not gonna be super hard. Like that coin problem on your homework where you had 48 different solutions, like I'm not doing that on your exam. You don't have time to do that. So don't like think it's gonna be a hard problem. It's gonna be something like you saw in your notes. So just make sure you remember how to do trial and error, how to do guess, check, and revise, how to draw a picture, how to use algebra, so on and so forth. Okay.
Number 6.
Number 6. Okay, so this one is kind of similar to what we did here. It's just it gave you a whole bunch of units here. Okay, so
Would that have you on the test? You'll give us a whole bunch of units? Or?
I mean, yeah, possibly, probably not, but yeah, it's the same idea. It's like here's the units, and we're trying to put them in base 3. So the way you would do this one is, I mean, I would count up how many units I have. 1, 2, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Let's see. So 18 times 3 plus 1, whatever that is. Let's see. I'm trying to do it in my head, but I can't do it. 18 times 3 plus 1. So that's 55 units right here, if I counted them right. So the idea is it's still base 3. So I'm going to have units, I'm going to have longs, I'm going to have flats. I'm going to have cubes here also. Let's see if it goes up 1 more. If you go up 1 more, 27 times 3, I think is 81. Yeah, 81. I don't have enough units here. I only have 55 units, so I can't make that. So I'm going to make cubes, flats, and longs and units out of this. So the first thing I would do is see if I can make a cube here. And you can, let's see. So it's 18, or let's see. This is 27 different. That's 27 units, so that would be a cube. And then you can do another set of 27. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's 27 more units. So that's also a cube. And then you have 1 unit left over. So that would be 2 cubes, 0 flats, 0 longs, 1 unit in base 3.
Okay, now I get it.
Does that make sense? What else? Do you know the difference between the takeaway and the comparison on 7A and B? Sometimes that's one that gets mixed up.
In comparison, you take away on both sides.
Yes. Yes. So for this one was 8 minus 5. So takeaway is you literally draw 8 of something, 4, 5, 6, 7, 8, and you're taking off 5. 1, 2, 3, 4, 5, and that's showing 8 minus 5, and your answer is 3. And comparison is when you have 8 things and you put 5 next to it, and you take away 1 from each. So 1 from each. 4, 4, 5, 5, and your answer is what's left over. So that's comparison, and that's the takeaway. And so this is the 8, this is the 5, this is the 3.
Okay. Number 11.
Yeah. Real fast on this one, it seems silly, like when you're looking at it like this, it seems silly to even have a comparison model. And when you're starting off with like super easy problems like this, it's totally true. Like if you're teaching like a 4-year-old, like if you have 3 pins and you take 1 away, you take it away, how many are left over? 2 are left over. But when we start getting into, is that on here? This base 10 blocks with that number is really hard to take away 476 in your head from your base 10 blocks. So that's when you start using the comparison, whenever you have a lot more of them. Yes, number 11 is, 12 specifically is the one I want to go over. 11 is, you just need to make sure, like I'm going to give you a word problem and I want you to tell me, is it join, is it comparison, is it separate, is it part, part, whole?
Okay, because I
So-
thought it mean write our own.
I mean,
word
yeah, it was
problem.
just practicing that. So you're not actually going to ask you to write a specific word problem for it, but you need to be able to identify what kind it is. So remember the join and separate. That's when you're adding things in or taking things away, like when things are like actually being like removed from the problem or added into the problem. Comparison is when you have 2 different sets of things and you compare them, and then part, part, whole is like we have donuts like half for strawberry and half for chocolate, you know, like that sort of thing. But let's go over 12 because B, C, and D is like the most missed part on the test, I feel like. So look at number 12. It says Jenny has 17 cookies. Betsy has 11 cookies. How many more cookies does Jenny have than Betsy? Okay. So for part A, here, let me make it where you can see both of them. There we go. Okay, so for part A, what kind of problem is this? Did we take cookies away or do we add them in?
And so would it be join, change, unknown?
Okay, join is whenever like Jenny had 17 cookies and she got 3 more. Like 3 more were added to her hand. We're comparing Jenny's cookies versus Betsy's cookies. So this is a comparison problem. And what's the unknown here? How many more cookies did Jenny have than Betsy? I'm trying to remember what was the wording we used on this? I guess the change unknown. Difference. We used difference, didn't we? Is that right? Difference unknown, I think, is actually what it is. I mean, if you wrote change, I wouldn't count it wrong. The big thing I want to focus on was the B, C, and D. Sorry.
I think in the videos it was change unknown.
Oh, I was right the
what
first
you
time.
were saying.
Okay,
Yeah.
thank you.
I was
Either one,
trying to
it's
think.
fine. It's the same thing. Okay, so for part B, C, and D is really what I want to focus on. For part B, it says describe in detail. These all say young child. It's not talking like specifically the age of the child. Like just how would a child in this type of thinking talk about it versus this type of thinking versus this type of thinking. So direct modeling, that is like literally having 17 of something and taking away 11 of something. Okay, so that would be this type of thing. You can do takeaway, you can do comparison, it doesn't matter. But that would be have 17 cookies or have 17 counters or have 17 Cheerios or whatever, have 11 and then compare them and see who has more. Okay, so for that part, we would say like, you might just say like model with counters or Cheerios or whatever you want to model with. And so Betsy would be, oh, so let's do Jenny first. Jenny would have 17. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17. Betsy would have 11 cookies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we're trying to see how much more Jenny has than Betsy. So you could take away at this point. So mark them off one at a time. And you can see that Jenny has 5 more cookies than Betsy. So yeah, the answer would be 17 minus, I said 5. It's supposed to be 6. What did I
I
do?
was like, I think
One,
I'm category.
2, 3, maybe I did. 1, 2, 1. Oh, here's one down here. I didn't see this one. It's supposed to be 6. 6, there we go. Okay, so she has 6 more, Jenny has 6 more than Betsy, and that's direct modeling. The next way to do it is the counting method. So direct modeling is literally putting 1 dot for every single thing in the situation. The counting method is using your fingers to count, but you're not using a finger for every single thing here. Okay, so if you have worked very much with like any pre-K all the way up to like second-ish grade, whenever you ask them to add 2 numbers, whenever you ask them to add 7 plus 2, they're literally going to count up 1, 2, 3, 4, 5, 6, 7, and then count up 8, 9. So it's like they count the 7 first, and then they count up the 2 more after that. And it gets really frustrating. Like right now, my son's in 2nd grade, and we're adding numbers bigger than 10. So I'm like, add 7 and 8, and he's like, I don't have enough fingers, I can't do it. And so it takes a lot of time for them to get up to this next method. And this is a great example of it because you can't do this problem with your fingers. You can't count up 17 and then take away 11 fingers because you don't have enough. So this is where you're starting with the idea of starting with 11 and then counting up to see how much it takes to get to 7. Okay, so I'm going to start with the number 11. I'm going to count up to 17. So the first finger, so I'm going to start with 11. We'll write that down. Start with 11. The first finger would be 12. The next finger would be 13. These are terrible fingers, but whatever. The next one would be 14. The next one would be 15. The next one would be 16. And that's technically one hand now. So I got to go over here on this. And this one would be 17. So it's 6 fingers. And you could do this a couple different ways. I think this is, you could also count down fingers. No, you don't have 17 fingers. So this would have to be the way you do this. But if it was a different type of problem, let's say this wasn't a subtraction problem. Let's say the problem was, 8 plus 5. If you were going to do this problem using the count method, you would not count 8 fingers and then count 5 more fingers up. You would start off with the number 8 and you would count up 5 more fingers. 1, 2, 3, 4, 5. So there's my 5 fingers. So I would start with 8. So the first one would be, so start with 8. The first one would be 9, 10, 11, 12, 13. So do you see the difference between counting method versus direct modeling? Like with direct modeling, you're literally counting every single dot and like putting a number with every single dot. And counting method, you're only counting up one of the numbers or counting down one of the numbers. Questions about that one? Okay, and then for part D, a number fact strategy. So the number facts that we talked about in the videos were doubles or making tens. For this specific problem of we're doing 17 minus 11 equals 6, I don't feel like it's really a number fact or a double or a making 10 problem. So this would just be one that, I mean, I wouldn't give you this problem on the test because it doesn't make sense to explain for that one. More the idea, let's go back to the 8 plus 5. If I wanted to do 8 plus 5 with making tens, the way I would do it with making tens is, I would say 8 plus what makes 10? Well, 8 and 2 make 10, but we need to add 5. So how much more is 5 than 2? Well, it's actually 3 more. So I need to add 3 more to get to 13. And this is the 5 right here. The other way to make tens here is if I did the 5. 5 plus 5 is 10. So I have the 5 here. I needed to add 8. I only added 5, so I have to add 3 more. And this 5 and 3 is 8. So either one of those is a way to use a making 10 strategy to add 8 and 5. And probably, I would assume, this is what I do in my head. Like, I don't know off the top of my head, sometimes 8 plus 5 is 13. I literally take 2 from the 5 to make 10 and then add it to get to 3. Some people also do doubles with that. I think I'm too old for doubles. I think doubles is a newer thing. But if you did doubles for 8 plus 5, you add your 8 doubles. 8 plus 8 is 16. Well, I only needed to add 5, not 8. So I added 3 too much. So I'm going to take away 3 to get 13. And that 8 minus 3, that's the 5. The other double you could do here, you could do 5 plus 5. That's kind of a 10 here, just because the 10 and the double is the same thing. 5 and 5 is 10, but I really needed to add 8, so I have to add 3 more to get to 13. And again, the 5 and the 3, that's the 8. Okay, so does that make sense how to do the 3 different levels there? The direct modeling, the counting, and the number fact there? Okay. What else?
Okay, can you do one?
Number 1?
Mm-hmm.
Uh-huh. Okay, so 684. We want to use base 10 blocks to show that. So remember, the unit is worth 1. The long, you can write it just like that, is worth 10. The flat is worth 100. And the cube is worth 1,000. I think I actually got them out in the video. I have them here. Like we actually have, there's the flat, and if you counted up each individual unit, there's 100 units there. There's the long, and here's the units for that. There you go, you can see that better. But to do 684, I wouldn't want to count out 684 units, right? That would be a lot of work. So instead, let's use 600s. There you go. 600s. So I'm going to use 6 of these flats. 1, 2, 3, 4, 5, 6. So that would be 600. And then So it's decomposing this number, and this is something that students in kindergarten, kindergarten, there aren't quite numbers as big. First grade, they can decompose this number by the end of first grade, for sure in second grade. So they can say that's 600s, that's 8 10s, and that's 4 1s. So 600s, you put 600s there, 8 10s would be 8 longs, and then 4 units.
Okay, I get it.
What else?
So with 2, will we just be, okay, keep going with 2.
Number 2, labeling the drawing to show units that correspond with the base 7 blocks. 4, okay, so this is in base 7 this time. So remember with base 7, the unit is 7 to the 0 power, which is just 1 unit. The long is 7 to the first power, which is 7 units. The flat is 7 squared, which is 49 units. So in base 7, if I have 4 flats, 2, 3, 4, and I have 0 longs, so no longs, and then I have 3 units.
Oh, okay.
So it says determine the total number of units. Let's see. So remember each flat, this is 49 units, this is 49 units, this is 49 units, this is 49 units, and then this is just 1, 1, 1. So to figure out the number in base 10, it would be I have 4 flats, each of them are 49 units apiece, plus 3 units. Each of them is 1 apiece. So 4 times 49 would be 196. 3 times 1 is 3. That would be 199.
Oh, okay. Yeah, I get it.
And
draw the picture and then solve it.
yeah, and the number of units, this is base 10. Like that's the number in base 10 form.
Will we still have to put base 10?
Well, it said determine what are the total units in base 10. Like the number of units is always in base 10. Like when you count up the pieces, it's always base 10. What else?
Okay. Number 4, that's all I got to do.
Number 4. So go from base 7 to base 10. So the number is 6351 in base 7, and I want to change that to base 10. So I basically just need to figure out how many units are here. It's essentially the same as the problem before. You could literally draw it out if you wanted to. 6 cubes, 3 flats, 5 longs, 1 unit. Or you could just think about the place value if you didn't want to draw each thing out. So 6, 3, 5, 1. Again, this is the units place. So this is the 7 to the 0 power. This is the long, so 7 to the first power. This is the flat, 7 to the second power. This is the cube, 7 to the third power. And then if you wanted to draw it, again, you could, or you could just do, where's it at? This step that we did before, just the multiplication to figure out how many units we have. So it's 6 times 7 to the third power plus 3 times 7 squared plus 5 times 7 to the first power plus 1 times 7 to the 0 power. 7 to the third power, I think, is 243. Let me see. 49 times 7. Oh, 343. Oh, I got that wrong. So it's 6 times 343 plus 3 times 49 plus 5 times 7 plus 1 times 1. So that is 2,058. 147. Double check, since I'm not doing awesome today so far. Yeah, 147. 5 times 7 is 35. 1 times 1 is 1. And then when I add those up, I get 2,241. Let me double check that. 147 plus 35 plus 1. Yeah. So the way you put it in base 10 is just to expand the number.
Okay. And to go from base 10, you just make the number smaller.
To go the other way, you take this number and you have to figure out the biggest thing in base 7 that fits into it. So a unit is worth 1, a long is worth 7. Obviously, there's 7 things there. A flat is worth 49. There's obviously 49. A cube is worth 343. The next one up from that is times 7, 2,401 units. I don't have the thing big enough to make that. So then you just are figuring out how many of the cubes can I get out of it? How many of that? How many of that? She has to do number 3. So there you go. Number 3 is the other version of that. So let's do number 3. Number 3 is we're going from the number 183 into base 4. So if I'm trying to go into base 4, it's like I need to figure out how many place values, like how big do I go up here? So this is where I'm figuring it out. Obviously, I'm going to have a unit, 4 to the 0 power. There's for sure going to be enough units for that. 4 to the first power, the longs take 4 units to make a long. I have enough units to make a long. So then I figure out the flat. 4 to the second power is the flat, which is 16. I have enough units to make a flat. 4 to the third power is 64. I have enough units to make a cube. That's a cube there. I have enough units to make a cube. The next one up is, I'm guessing 216. I don't know though. Let's see. 256. 256. See, my guess is off. 256. I don't have enough pieces to make this because I need 256 pieces to make it. I only have 183. So that's too big. So the place value that I'm gonna have in my answer is going to be a 4-digit number, 1, 2, 3, 4. Okay, so I'm gonna go ahead and put blanks there. I have a place for 4 to the third to go, 4 to the second, 4 to the first, 4 to the 0 power. And then from there, I want to figure out how many of each of these would fit in there. Start off by taking the biggest amount first. So how many 64s can I get out of that? So you can get, let's see, 2 of them is 128. 3 of them is 192. I don't have enough for 3 of them. I only have enough for 2 of them. So 183 minus 2 cubes would be 183 minus 128, which would be 55 pieces left over to work with. So if I have 55 pieces left over to work with, and I want to make flats now, it takes 16 pieces to make a flat. So how many would fit in there? 16 times 2 is 32. 16 times 3 is 48. So I can make 3 of them. 16 times 4 is too big. It's 64. So I can make 3 flats now. So subtract off those flats that we make. So 55 minus 48 is 5, 6, 7 pieces left. So I have 7 pieces left. Now I'm working on units now. There are 4, I'm sorry, not units, longs. There are 4 pieces in a long. If I have 7 pieces, how many longs can I make? 1. 7 minus 4 is 3 pieces left over. And so that's units. I have 3 units left over.
Okay.
So my answer is 2, 3, 1, 3 in base 4. What else?
Ooh, okay.
13.
Mhm.
Okay. For 13, remember cardinal is a counting number. So write a sentence where you count 12 of something. So there are 12 students in the room. Something that you can count 12 of.
Oh, okay.
Ordinal means order. So you need to use 12 as an order number. So like the 12th of something. The 12th thing I did this morning was put on my shoes, or I was 12th in line, or something about 12th. I'll say I was 12th in line. And then the other one is nominal. Nominal, it means name. So you need to use 12 as a name, which is kind of weird. Usually when we use numbers as nominal numbers, they're a bigger number, like an ID number or a phone number or an address. So you can say, let's say, let's do a Jersey number. He was, or he is number 12 on the team. You could also say, my ID number is 12. Your address is a nominal number. So I live at 12 Baker Street.
Okay.
Because 12, it's not like the 12th house there. It's not like you're counting up 12. It's just a number representing a location. Okay, anybody have anything else? I think we've gone over everything. The only thing we didn't go over is like the lattice, partial sums, adding up, missing addend. Anybody have any other questions?